Welcome to Lesson 5.1. Today we're going to talk about writing equations and inequalities. Our learning objectives: be able to write equations and inequalities, be able to check solutions to equations, be able to check solutions to inequalities, be able to solve real-world problems using an equation. In algebra, an equation is a mathematical expression that contains an equal sign. It tells you that two expressions represent the same number. For example, y equals 12x is an equation. An inequality is a mathematical expression that contains inequality signs. For example, y is less than or equal to 12x is an inequality. Inequalities are used to tell us that an expression is either larger or smaller than another expression. Equations and inequalities can contain variables and constants. Variables are usually given a letter, and they are used to represent unknown values. These quantities can change because they depend on the other numbers in the problem. Constants are quantities that remain unchanged. Equations and inequalities are used as a shorthand notation for situations that involve numerical data. They are very useful because most problems require several steps to arrive at a solution, and it becomes tedious to repeatedly write out the situation in words. So here are some examples of equations. We've got x squared plus 1 equals 10, 3x minus 2 equals 5, x plus 9 equals 2x plus 5, and x over 3 equals 15. Notice how they're equations because every single one of them has an equal sign. For inequalities, we have the following symbols. We have greater than or equal to, less than or equal to, and not equal to. This one we're not going to use very often, but it's still nice to know what it means. Here are some examples of inequalities. 3x is less than 5, 4 minus x is less than or equal to 2x, x squared plus 2x minus 1 is greater than 0, and 3x over 4 is greater than or equal to x over 2 minus 3. Again, these are all inequalities because they have the inequality symbol in them. The most important skill in algebra is the ability to translate a word problem into a correct equation or inequality so you can find the solution easily. Going from a word problem to the solution involves several steps. Two of the initial steps are defining the variables and translating the word problem into a mathematical equation. Defining the variables means that we assign letters to any unknown quantities in the problem. Translating means that we change the word expression into a mathematical expression containing variables and mathematical operations with an equal sign or an inequality sign. So the first thing we're going to do is we're going to work on writing a sentence based off of the word equation. So define the variables and translate the following phrases into equations. First one, a number plus 12 is 20. So first of all, a number. Okay, we're going to use n because n is the letter that starts number. A number plus 12, when they use the word is, that means equals 20. So a number plus 12 is 20 is the same thing as n plus 12 equals 20. 9 less than twice a number is 33. Twice a number, that tells me to use 2n. 9 less than that tells me to do minus 9. Is means equals 33. So 9 less than twice a number is 33 is the same as saying 2n minus 9 equals 33. 5 more than 4 times a number is 21. 4 times a number, 4n. 5 more plus 5 is equals 21. So 5 more than 4 times a number is 21. 4n plus 5 equals 21. And the last one, $20 was 1/4 of the money spent on pizza. So now we're switching it up. We're going to say money. So we're going to use M. 1/4 of the money. So that means a fourth. A quarter of the money was $20. Okay? Was is just like is. It's what we mean for equals. So $20 was 1/4 of the money spent on pizza. Would be the same as taking 1/4 of M equals 20. So now we're actually going to not only write the equation, but we're going to solve it as well. So this first one, we've got working for 2 hours and packed 24 boxes. Okay? So 2 hours, that's the same as 120 minutes. They packed 24 boxes. So if you take 24 times the number it took for each box, you would get 120 minutes. So 24 times B equals 120. So to solve for B, I divide by what's in front of it. And if I divide one side, I have to divide the other as well. So the 24s cancel off on the left, leaving me with just b. If I type 120 divided by 24 into my calculator, I get 5. So it took 5 minutes to pack each box. For the next one, after a 20% discount, the book costs $12. Okay, so we're using a book, so I'm going to use the variable b. So if I take the price of the book minus 20% of the book, remember 20% is 0.20 times b, I get 12. So if I have 1b minus 0.2b, I can subtract those away, leaving me with 0.8b. Okay, now to solve for b, divide by what's in front of it. So divide both sides by what's in front of it. And if I do that, I get an answer that the book cost $15 before the discount. So now we're going to do the same thing but with inequalities instead. So now we got the sum of 5 and a number. Sum means plus. So if I take a number plus 5, and that would be the sum of 5 and a number. Less than or equal to is this symbol right here, 2. So the sum of 5 and a number is less than or equal to 2 would be the same thing as n plus 5 is less than or equal to 2. The distance, so my variable is d, from San Diego to Los Angeles is less than 150 miles. So I would say d is less than 150. Diego needs to earn more than 82 on his test to receive a B in his algebra class. Okay, so since we're talking about a test, I'm going to use the variable t. T needs more than, when we say more, we need greater than 82. So I would say that t needs to be greater than 82. And for the last one, a child needs to be 42 inches or more to go to the roller coaster. So child, we're going to use C. 42 or more. When they say or more, that means greater than or equal to. And 42. So the child needs to be greater than or equal to 42. So once we've solved equations, we'll often need to check solutions to make sure that it is actually an answer. In math class, checking that you arrived at the correct solution is very good practice. We check the solution to the equation by replacing the variable in the equation with the value of the solution. The solution should result in a true statement when plugged into the equation. So we're going to check that x equals 5 is the solution to the equation 3x plus 2 equals negative 2x plus 27. So what I'm going to do is I'm going to take 5, and wherever I see an x in the equation, I'm going to replace it with 5. So instead of 3, I've got 3 times 5. Instead of negative 2x, I'm going to have negative 2 times 5. And what should happen is I should get the same number on both sides of the equal sign. So on the left, 3 times 5 is 15. 15 plus 2 is 17. On the right, negative 2 times 5 is a negative 10. Negative 10 plus 27 is 17. The fact that I get the same number on both sides means that it works and that 5 is a solution. So now we've got x is a negative 1/2. So now wherever I see an x, I'm going to put a negative 1/2. So I've got 3 times a negative 1/2 plus 1 should be equal to a negative 1/2. 3 times a negative 1/2 is negative 1.5. And negative 1/2 is negative 0.5. Negative 0.5 plus 1 is negative 0.5. So I get the same thing on both sides so that it works. It is a solution. For the next one, I've got that y is negative 1. So wherever I see a y, I'm going to put negative 1. So 3 times negative 1 plus 5 is equal to negative 2 times negative 1. 3 times negative 1 is negative 3. Negative 2 times negative 1 is 2. Negative 3 plus 5 is 2. I get 2 equals 2, and that is a solution. Go ahead and pause the video and do the last one on your own. then hit play and see how you did. So plugging in a 3 for z, you should have gotten 3 squared plus 2 times 3 equals 8. 3 squared is 9, 2 times 3 is 6. So I got 9 plus 6, which is 15. My equation says 15 is equal to 8, which is not true. So therefore it is not a solution. To check solutions for inequalities, we do the same thing. We plug our answer in for the variables and we see if we get a true statement when we substitute it in. So now we're going to check that a given number is a solution to the inequality. So we're going to do the same thing we did before. So I'm going to take 10 and I'm going to plug it in for a. So I'm going to get 20 times 10 less than or equal to 250. 20 times 10 is 200. And my job is to figure out if 200 is less than or equal to 250, which it is. So therefore, it is a solution. Same thing for the next one. B is negative 2, so wherever I see a negative 2, wherever I see B, I'm going to put a negative 2. So I've got 3 minus negative 2 over negative 2. 3 minus a negative 2 turns into 3 plus 2, so I get 5 over negative 2. 5 divided by negative 2 is negative 2.5. So negative 2.5 greater than negative 4. That is true. So that is a solution. For our next one, I'm going to put 3/4 in for x. So I'm going to have 4 times 3/4 plus 5 less than or equal to 8. 4 times 3/4, if you type that into your calculator, you get 3. 3 plus 5 is 8. So my inequality is 8 is less than or equal to 8, which is true. So that means that it is a solution. Go ahead and pause the video and do the last one on your own, and then hit play and see how you did. If you plug 25 in for z, you should get it down to 6 is less than 5, which is not true, so that is not a solution. We can also solve real-world problems using equations by doing the same process that we've been doing. So tomatoes cost 50 cents each and avocados cost $2 each. Ann buys 6 more tomatoes than avocados. Her total bill is $8. How many tomatoes and how many avocados did she buy? So if her total is $8, we're going to set it equal to 8. We're going to use T for tomatoes. So 50 cents for tomatoes. And we're going to use A for avocados, $2 for an avocado. Okay, so we got 2 different variables here, and we don't know how to do that. However, there's one piece of information that they give us. There are 6 more tomatoes than avocados. So what we can do is, instead of A, we can do the number of tomatoes minus 6. Because there's 6 more tomatoes than avocados. So I can do 0.5t plus 2 times t minus 6 is equal to 8. Distribute the 2, and I get plus 2t minus 12. Add my like terms together, and I get 2.5t. Add 12 to both sides. Divide both sides by the number in front, and I get that there are 8 tomatoes. Well, then to figure out how many avocados, I would take the 8 minus the 6, because there's 6 more tomatoes than avocados, and that would get me 2. So there's 8 tomatoes and 2 avocados. To organize a picnic, Peter needs at least 2 times as many hamburgers as hot dogs. So the number of hamburgers needs to be at least, so greater than or equal to 2 times the number of hot dogs. Well, we'll just use D for dogs because they can't use the same letter for both. Now we're told that he has 24 hot dogs. So if I plug 24 in for D, I would get that the number of hamburgers needs to be greater than or equal to 2 times 24, which is 48. So he needs at least 48 hamburgers. So to review, to solve for the variable within an inequality, substitute an equal sign in for the inequality until you have solved for the variable, and then replace the inequality sign to show your possible solution set. Remember, when you multiply or divide by a negative number when solving for a variable, the inequality sign must switch to the opposite in order to solve accurately for the variable. An equation is a mathematical expression that contains an equal sign. An inequality is the mathematical expression that contains inequality signs. Variables are usually given a letter that they are used to represent unknown values. These quantities can change because they depend on the other numbers in the problem. Constants are quantities that remain unchanged. Defining a variable means that we assign letters to any unknown quantities in the problem, and translating means that we change the word expression into a mathematical expression containing variables and mathematical operations with an equal sign or an inequality sign.